Hello, everyone. Welcome to our workshop, Mapping ISA 95 to MQTT Spark Plug using Ignition and HiveMQ Cloud. Allow me to introduce you all to our presenter, Kudzai Menditeritsa, who is the developer advocate at HiveMQ, and he will show you today how to use Ignition to collect data from PLCs and publish it as a ISA 95 compliant objects to an MQTT broker cluster on HiveMQ Cloud. Before we kick off, I would like to share that we are recording this session. And if you have any questions during the session, please feel free to add them to the Q&A pod. Now, without further ado, I will hand it over to Kudzai. Welcome, everyone.
Thank you, Jayashree, and welcome to everyone. Thank you so much for joining us for this workshop. Yeah, so my name is Kudzai Menditeritsa. I'm a technology communicator and electronic engineer. I'm based out in Germany, and I'm a developer advocate here at HiveMQ. And my role here really includes creating content to help engineers adopt MQTT for their industrial IoT projects. So I also run a popular YouTube channel and podcast where I teach and talk about smart manufacturing. So there's my email there and also my LinkedIn in case you need to reach out to me regarding this and other issues concerning industrial IoT. So a bit about HiveMQ. So HiveMQ was founded in 2012 in Landshut, Germany. And basically what we do is we help companies connect devices to the internet. Our MQTT platform makes it possible to move data from device to cloud in a secure, reliable, and scalable manner. And we've got over 130 customers that trust our solution. And we are a venture-backed company. We've recently raised 49 million euros in seed and Series A funding. And some of our clients include Audi, BMW, and Siemens, and Daimler. Okay, so I'm going to begin here by taking you through some slides to explain the benefits of mapping ISA 95 shop floor architecture to MQTT Spark Plug. Now, in the interest of time, I'm going to assume that most of you on the call here know what MQTT Spark Plug is and how it works. So, but however, even if you do not know, you should be able to understand the concepts that I present on this session. So why are we talking about mapping ISA 95 to MQTT Spark Plug? Now, this is all against the backdrop of the digital transformation trend that's going on in manufacturing. So, because the reason is that for you to be able to digitally transform a manufacturing operation, you need to have in place a data architecture that enables the components of your manufacturing facility to easily and contextually exchange information from things such as your field equipment, your SCADA, MES, and also your enterprise applications. Now, the good news is that we do have a shop floor data architecture, and that is ISA 95. So in short, ISA 95, what it does is that it looks at the most common activities that go on inside a manufacturing facility. For example, things like scheduling a batch or tracking some raw material usage and so on. And from that, they try to come up with a standardized model of exchanging information from all those different activities. So just to show you what the ISA 95 architecture looks like. So this is what the architecture looks like. Basically, what we have here is that we've got a categorization of information according to the physical location of the source of that information in a manufacturing facility. Now, this makes it easy to find information and also understand the context of that information because you know where it is being produced, right? So as you can see here, ISA 95 uses a hierarchical approach to structuring information sources in a manufacturing enterprise, starting with the enterprise-wide information at the top, followed by information that is emanating from a site. And then we've got the area, and within that site, And if you are like from the discrete manufacturing, what follows is the production line, or that could be the process cell if you are into batch processing. And further down the hierarchy, we have got the work cell or the unit. And within a work cell or unit, this is where you then find your PLCs and other field equipment. So that's the hierarchical structure that ISA 95 uses to actually indicate where information is coming from within an enterprise. So this is a standardized approach such that when components are consuming information, they can relate to how it is being produced. They've got context to exactly where from the organization this information is being produced. So now there is a challenge, however, with the ISA 95 architecture. More precisely, there's a problem with the way that it is being implemented, because the ISA 95 architecture itself does not determine that it should be used, it should follow a certain data movement or architecture. But traditionally, we've seen this ISA 95 being implemented using this automation pyramid, which I'm sure many of you on this call are familiar with. So the idea here is that components in a manufacturing facility are grouped into different levels based on how long it takes for a component to complete a process. For example, at the highest level, it may take weeks to plan and execute a production schedule. And whilst at the lowest level, it may take literally milliseconds for a valve to open and close. So that's the grouping. It's based on time. And how it works is that the information moves from the lowest level going to the next level, and then up until it reaches the high level where we've got your business planning and logistics. Now, the implication of this is that even though information is represented in ISA 95, it can only move from one level to the next until it gets to the top and then back down again. So as you can tell, this is not like the most efficient way to arrange components if you intend to achieve digital transformation, because digital transformation is all about the flexibility of being able to communicate. Each component should be able to communicate with whatever component as and when it gets information, or each component should be able to retrieve information as and when it needs it, without having to wait for that information to propagate to across or through different levels. Okay, so now what would be a more suitable smart manufacturing architecture is a hub and spoke model. And this is the model that an MQTT Spark Plug network architecture uses. So in this architecture, components do not exchange information by directly passing it from one component to the next as it propagates up the. Instead, all participants publish information to a central repository of information, which is an MQTT broker in this case, and any other participant that may be interested in consuming that piece of information can pull it from the MQTT broker. So this makes your broker like a single source of information, and therefore it becomes easy for other components to autonomously make decisions based on that information that is coming from the broker, because whatever is on the broker is the actual current state of the entire enterprise. So there's integrity in knowing that, because you can then go on to take actions knowing that this is the current state of the MES, this is the current state of the robotic arm, without having to wait for that information to be passed from different components before it reaches you, right? So now there is a challenge, however, with the MQTT Spark Plug network here. So what you're looking at right now is the hierarchical MQTT topic namespace representation, which is what is used to indicate the source of information in a plant network. So the challenge here is that organizations may interpret this topic structure differently, right? So we've got group ID, we've got edge node ID, we've got device ID. So the idea here is for you to be able to group your components within a plant flow. So ideally, you'd want to group your components in a production line under edge node ID, or in a cell, you want to group them under device ID. But the idea here is that there is no agreed convention to how organizations should use this topic namespace to actually create that. So you'd end up having a situation whereby we've got different implementations of the topic namespace, even though in itself it is standardized, but it's not an industry-wide kind of adoption that would help you know exactly how to structure that information. So this brings us to our topic of the day, which is you can actually take advantage of the tried and tested data architecture like ISA 95 and map it to this more flexible architecture, which is the MQTT Spark Plug network. So in this case, we can use the area, line, and cell of the ISA hierarchy, as I highlighted earlier. So that could be our group ID, edge node ID, and a device ID, respectively, in the MQTT Spark Plug topic namespace. So as you can see, these can actually directly map to each other, and you've got guaranteed that you're using ISA 95, which is a widely accepted standard. And you know that everyone is using this approach. And also, if you already happen to implement ISA 95 within your organization, you're essentially just changing the architecture from being a pyramidal architecture to like a hub and spoke model, but you're not really changing the functional position of your components within a manufacturing environment. Now, if it so happens that you have got like more components down the line, so within a cell where you've got your PLCs, so and you need to extend your hierarchy. So because the topic namespace alone only gives you about 3 elements where you could put your ISA 95 components. So if you need to extend that further, the good thing about Spark Plug is that the name property of the Spark Plug metric allows you to actually represent a hierarchy. So you could actually extend your hierarchical structure within the metric itself. So by using the hash the backspace where you've got PLC1 and then /tag, and then if you've got many more other elements down the hierarchy, you could use that to represent it. Right, so I think it's time for a demo. Now it's now time for a demo. So I think if you can see behind me here, I've got like a demo station. So there I've got a Schneider PLC, and then I've also got an Opto22 Groove Rio. So a Schneider PLC is actually measuring data from these 4 to 20 indicators, these signal transmitters, and then exposing it via Modbus. And the Groove Rio is actually exposing information via OPC UA. So we're simulating a boiler in this instance. And so this is typically the kind of devices that you'd find within a cell or within a unit, and you want to be able to collect information and publish it to that central repository of information using that ISA 95 kind of mapping. So I'm going to go into my Ignition platform here to show how we're able to use Ignition to read information from these devices and then publish it using ISA 95. But before I actually go there, I'm just going to quickly show you what I have here. So this is my machine expect, Schneider machine expect. Just to show you here, I'm actually simulating tank level using the analog input channel on the PLC. So as you can see here, we're actually getting 939. It's got a scaling of 0 to 1000, right? And then here I've got a Groove Rio management platform. So as you can see here, I've got also some analog inputs that are simulating our boiler temperature, output steam flow rate, and feed water flow rate there. So all of this information is being exposed via OPC UA server. So now if I go to my Ignition platform here, under config. Okay, so I need to relog in. Yeah, so under config here, so you can see that if I go to OPC connections, so you see here, I've got my Groove Rio. So this is how I'm able to actually collect data from downstream devices into Ignition platform. Right, so if I, for example, say, if I use my OPC client here, so you can see that I'm actually reading this information from the controller. So if I read here, so you can see we're reading this information. So the temperature in my room is currently 25 degrees Celsius, right? So we're successfully reading that OPC UA information from the Groove Rio. And I also have other device connections. So I've got the Schneider PLC. So I'm reading using Modbus TCP. And then you can see I'm also connected to it. And in addition to this, just to generate some more data, I'm actually simulating a data simulator, which comes, it's a sample that comes built into the Ignition platform that allows us to sample that information. Right, so just to give you a visual of this information, so you can see here, this is our dairy farm. So this is the refrigeration where of the dairy farm where we're simulating all of this information. So this is the simulated data. And then if I go to the home here, you can see I've got my tank level. And then if I turn it down, you can see that information is going down. So that's typically you have a SCADA representing that information. So what we want to be able to do is to package that information in a way that it gets pushed to the broker representing that ISA 95 kind of structure, right? So I'll go back to my Ignition platform. So Ignition comes with a module for transmitting MQTT messages called MQTT transmission, which is from Cirrus Link. In fact, you actually need to install this module from Cirrus Link that allows you to transmit the tags that are within your that you're collecting from downstream devices into an MQTT broker. So if I go to the settings of my MQTT transmission here, and then under transmitters, so I've got a transmitter called All System Tags. So you can configure different transmitters based on how you want that information to be transmitted using MQTT. So if I click on edit here, so if I scroll down here, so here, as you can see, this is where I'm putting my Spark Plug settings. So, so under group ID, this is where you use your plant area, right? To actually map that into the MQTT's topic namespace. And then the edge node ID, this is where you put your process cell. And then on device ID, this is where you put your unit to actually create that topic namespace. So that's what the Spark Plug topic namespace accepts. So once you put these elements on these settings of the Spark Plug transmitter, you need to extend it because now we still have those PLC. We don't know where information is coming from, which PLC, because we've got information from a Schneider PLC. We've also got information from a Groove Rio remote IO device. So in your ISA 95 hierarchy, you need to know where exactly is it coming from, which PLC. So to complete that structure, I'll go into my Ignition Designer, right? So here you can actually then create folders within Ignition Designer under your tech browser to then put those tags, to assign those tags under folders to then create that hierarchy. So this is the hierarchy that then goes on to your metric name. So Spark Plug is able to actually consume this tag hierarchy or this tag organization within Ignition, and then use that on the topic metric name of that payload of the Spark Plug payload. So as you can see here under OPC UA device, I've put all my tags here, created a directory and put all my tags that are coming from the Opto22 under this. And then for the tag that is coming from the Schneider PLC, I've also created a directory and put that inside there. So by doing that, I'm essentially creating a hierarchy that can be consumed by the MQTT transmission module and put on the metric name of the Spark Plug payload. So also under your simulated refrigeration, you can see I've got these values that I've put under that directory, right? So now we've got all of this information that is being published. So if I could go back to my, I'm not sure if you were actually seeing my Ignition Designer 2. Okay, so that's the Ignition Designer tool. So in case you actually could not see what I was talking about here, so this is the tech browser where you are able to arrange your tags by creating directories. So under here, you can literally just create a directory here, and then you import those tags from Ignition Designer. And this directory is where you're able to then put all of those tags within that directory to create that hierarchy to extend your ISA 95 format, right? So here I've also got Schneider Modbus device where I'm putting that level value into that directory. So by doing that, essentially, I'm creating that hierarchy that can be consumed by my MQTT transmission module so that it can be published to the MQTT broker as a complete ISA 95 object, right? So if I go back to my Ignition Designer here. So as you can see here under tech path, I'm not, so because I'm leaving it empty, what that means is that this is where the extension of that hierarchy begins within this transmission module. If I was to actually put, to say Schneider PLC path here, only those tags that are under that Schneider directory will be transmitted. So here I want all those tags to be transmitted. So which means each PLC is going to have its own hierarchy that will then be extended. It can be used to extend the ISA 95 format, right? So now we've got that information in our MQTT transmission module. We need to push it up to the cloud. So this is where HiveMQ comes in. So you could literally use a cloud, a managed service, HiveMQ Cloud. So you don't need to run any bare metal. You don't need to provision any virtual machines. If you're on AWS or Azure, you can literally just use this one. It allows you to connect up to 100 devices for free. So you simply sign in. Once you've signed in, if you're doing this for the first time, it will ask you to enter your email address, and then you're going to get a notification to confirm your email, and then you're able to log in. And then as soon as you log in, a cluster is already provisioned for you. So all you need to do is just to copy information of that cluster, like your broker URL. And also you can go into the cluster where you've got more information regarding the security settings of your cluster. So here I can copy this URL address and the port number. I know this is a 8883 because I'm using TLS connection. And also this is where you can manage a whole lot of different security configurations. And then here under access management, because also you need to protect your MQTT network so that only brokers that are authorized, only clients that are authorized can actually connect to this broker. So you could do that using some credentials where you've got your username and password. You're able to set those up here on this platform. And if you need to create a new cluster, it's just a matter of clicking a button, and then your cluster is up and running, and then you can simply copy the URL address and then put them on the Ignition platform. So now here I'll show you where I've put my broker URL address. So this is where I've got my HiveMQ broker URL address. So it's connected to my demo client, and I'm pushing that information as we speak to the HiveMQ, my HiveMQ Cloud MQTT broker. So now to see that information in action, so I've got an MQTT.fx, which is an MQTT client that allows us to actually subscribe to the HiveMQ broker and consume all of that information. So as you can see, that is information that is coming in real time from all of these devices that I've got connected here. And you can see I've got a refrigeration. And if I change there, you can see that we've also got information that is coming from my Opto22 OPC UA remote IO device. So here you can see this is the mapping that you see on this, because this Sparkplug Explorer tab allows us to actually get the directory as it comes in from the Ignition platform. So here you can see that we've got plant area as the group ID, which I specified, and we've also got the process cell as the edge node ID, and we've also got the unit as the actual production line or cell. Now, where do we see the information about the actual PLCs, the extension of that unified ISA 95 format? So as you can see here, we've got this metric here, but it's moving fast. So I've actually copied it here so that I could show you on a notepad. So this is the actual metric that we actually receiving on a MQTT Sparkplug node. So as you can see under name here, we've got this hierarchy that is being represented, because I've got a directory called simulated refrigeration in my Ignition designer. And from that, there's a variable or tag called temp suction. So it's got the timestamp, it's got the value. So this allows you to create that hierarchy extension that I was actually explaining to you about. And then here under Opto22 directory, we also have got the output steam flow rate, and we've also got the value there, which has got a representation of a float value that is currently sitting at 2,500 kgs per hour, I presume. So basically, this is how we are able to actually map your ISA 95 format to an MQTT Sparkplug network. So I know there's a lot to actually pack in there within a 30-minute session, but I hope this gives you an idea to then investigate further. But also, if you need some more information regarding that, feel free to reach out to me or to my colleagues at HiveMQ. Will be able to assist you with doing that. And just one other thing, because we also want to get a sense of whether you are implementing ISA 95 or you're using Sparkplug within your organization. We're going to put up a poll. Jayesh is going to put up a poll there. If you could kindly just answer those 3 questions, the yes and no questions, so that we could get a sense of whether you are actually using these technologies, and it will help us to actually prepare better content for you going forward. So thank you so much for attending this session.
Yeah, thank you so much, Kudzai. The polls are up now, and it was a fantastic session, and thank you for sharing your knowledge with the community. I hope the attendees found the workshop really useful. While the poll is running, maybe we can take up one question, which is from Thomas. So Thomas is asking, how do you separate sites if the group ID only represents the area?
So the site, what you do is you subscribe to the root. So the site actually subscribed to the root. If you subscribe to the root, you then get, so maybe if I could just quickly share my screen again. So as you can see here, we've got the Sparkplug version 1.0. So that's your root access. So if you subscribe to that, then this is where your site is subscribing to. And we've also got SCADA or some MES systems that actually want to have like site-wide access. So this is where they would also subscribe. They would also subscribe to that root access.
Thank you so much, Kudzai. I think we can take up one question and close the session, because we are really like on the top of the hour. So there is one more question, which is from Tushar. He's asking about Sparkplug topic namespace. Is it different from what we do in setting up MQTT hierarchy structure, or the way we represent MQTT wildcards?
So the MQTT Sparkplug topic namespace is different from the hierarchy of the MQTT in the sense that with the hierarchy of the MQTT, you need to hard code that. It's not a standard. It's not a standard way of representing the topic namespace. So the Sparkplug is a way of saying this is how your topic namespace need to be represented, such that all devices and all software that support MQTT Sparkplug can anticipate all the element within that topic. But if you do it on an MQTT hierarchy, only you or your system is able to anticipate or know how the arrangement of that topic is like. So Sparkplug is the idea behind it is to standardize on that topic namespace so that everyone understands how the topic namespace is laid out.
Thanks so much, Kudzai. So I think we will end the session. Thanks again, everyone, for joining us today. We hope you found this workshop useful. Feel free to reach out to us if you have any questions. Like Kudzai already mentioned, we do have a dedicated resource page which talks about MQTT Sparkplug. We have the essentials on our YouTube channel, on our website. Do check it out. You can also submit your questions to HiveMQ Community Forum. Yep. Thanks again. See you all next time. Thanks, Kudzai.
Thanks. Cheers. Bye.
Have a great day. Bye-bye.